Now the topic is Gauss law and its application. This question is very important for 4 marks in IPE exam. Many times this question was asked. Let's go to discuss the Gauss law. Before going to discuss the Gauss law, we want to know about the electric field lines. Suppose we take the positive charge, electric field lines are drawn. How? Look here, I want to electric field line vector drawn at a point P, which is at a distance r from the charge. We know that electric field intensity is nothing but force on unit positive charge. So we place unit positive charge here at the point P. Okay, positive charge plus 1 repels along this direction with some magnitude. Okay, so magnitude is nothing but here length of the vector, and this is the direction. This is the direction. Anyhow, this is electric field line vector at that point. If suppose point is away positive charge from the positive charge, suppose it is here. Now the distance is more, then length of the vector is less because electrostatic force is less here. Okay, so as going away field lines length is decreased. Anyhow, so for the positive charge, how to draw the field lines? Look here, suppose, okay, so these are electric field lines. Suppose we take the equidistance around the positive charge. Okay, so we get like this one. Suppose we take the negative charge. I want to draw the field line vectors for negative charge at the point P, which is at a distance r. Okay, so there is a test charge, that is unit positive charge. So unit positive charge is attracted by the negative charge along this direction. Okay, so these field lines are inward. Okay, for positive charge lines are outward, but for negative charge field lines are inward. Okay, so we draw so many vector field lines around negative charge, okay, in a space like this one. Okay, suppose there is a positive charge and negative charge. How to draw the field lines? Look here. So this is field line is coming out from positive charge and end at the negative charge. Okay, so like this one. Okay, suppose point P is here, so positive charge is repelled and negative charge is attracted. Okay, due to that resultant force may be act at this the point. Okay, suppose unit positive charge is placed here, unit positive charge is moving along this path. Okay, because continuously direction is changed, then we will get the curve. So these are the field lines we get like this one. We have a sheet has a positive charge plate. Okay, so what is the electric field lines? How to draw the electric field lines? Okay. A point P is placed here. Okay, unit positive charge here. So this is repelled by the sheet along this direction. Okay, so these are the field lines. Finally, we get like this one. Okay, for negative charge, for the negative charge sheet, so we get electric field lines like this one, because suppose point P is here, so this is attracted by the negative sheet plate along this direction. Okay, so these electric field lines are so useful to understand the some concepts. These are electric field lines. Okay, I take some unit area. Unit area. Okay. Okay, so this is unit area. Unit area means its area is, so here I take unit area plate. So here the field lines are passed through the unit area, and here condition is unit area should be perpendicular to field lines. ఓకే, సో ఈ ఏరియాని ఎలా ఉంచుతున్నామంటే, ఈ ఏరియా ప్లేట్ని ఎలా సెట్ చేస్తున్నామంటే ఫీల్డ్ లైన్స్కి పర్పెండిక్యులర్ డైరెక్షన్లో ఉండేటట్టు. సో ఈ యూనిట్ ఏరియా ప్లేట్ని పర్పెండిక్యులర్ డైరెక్షన్లో యూనిట్ ఏరియా ఈజ్ ప్లేస్డ్ perpendicular to the field lines. Okay, so some lines are passed through this unit area. Okay, total number of unit lines, so here we assume total number of lines passed through area is called electric field lines. Electric field intensity. Total number of lines passed through area, unit area. So here we reference take as total number of the lines passed through unit area is taken as a electric field intensity. Okay, electric, so this is taken as a reference. So at the point P, okay, see here, suppose charge is here, around it creates electric field lines. Okay, suppose a point P is there, point P is there, so I take the unit area around the point P, okay, so this is unit area. Okay, how many number of lines pass through this area? Okay, so these field lines are assumption concept, but it is very useful to understand further concept. So what is the assumption here? Suppose charge somewhere here. Okay, so the charge is here. Okay, so these are the electric field lines. Okay, blue color shows the electric field lines of the charge. Electric field lines at the point P. So immediately I take the unit area around the point P. I take the unit area around the point P. So total number of lines passed through unit area is called electric field intensity. So this is taken as a reference, but this reference concept is very useful to understand so many concepts. Total number of lines passed through unit area, that is electric field intensity. Through unit area, number of field lines are E. Suppose we take a area, how many lines pass through this one? That is simple logic, that is E into A. Suppose one pen cost is E rupees. Okay, now so I want A pens. So how much the cost for A pens? That is E into A. Yes or no? Like this one, for unit area, number of lines is E. So for area A, so number of the lines is E into A. Okay, so total number of lines is called flux. Total number of lines are passed through area is called flux. So flux is denoted by the a letter is pi. Okay, that is E into A. Remember, A is area is perpendicular to the field lines. Suppose area is not perpendicular to the field lines. Now how to take the problem? So to understand this one, first it is better think as a dimension, two-dimensional. Now the picture is in two-dimensional. Okay, so look here, this line I take here perpendicular to the field lines, projected this line perpendicular to the field lines, then we get this one. Now length of line is L. Now I want to project it perpendicular to the field lines this length, then we get like this one. It is rotated some an angle theta. What is this length? Now the length become, look here, suppose now I join this one, so I get here right angle triangle. You know that from the right angle triangle, okay, 90 degrees opposite mean hypotenuse. So here hypotenuse is L. So I want to here adjacent side. You know that what is the cos theta? Adjacent side by hypotenuse. What is the hypotenuse here? L. So what is the adjacent side? That is L cos theta. Okay, now. So this is L cos theta. So the projection of L perpendicular to the field line, then we get L cos theta. L cos theta. Look here, through L and L cos theta, same field lines are passed. Same field lines are passed. Okay, no? ఈ లెంత్ గుండా ఎన్ని లైన్స్ పాస్ అవుతున్నాయో ఈ లెంత్ గుండా కూడా అన్ని లైన్స్ పాస్ అవుతున్నాయి. రైట్, now let's go to now coming to this picture. Now area is projected to perpendicular direction. Okay, perpendicular direction to the field lines, then we get the like this one. So what is this area? If suppose it is shifted perpendicular projection to the field lines, then A cos theta. Okay, now area become A cos theta, where theta is angle between original place of area and perpendicular projection of field lines. So area become A cos theta. Number of lines passed through unit area is E. For now we have area is A cos theta. Then what is the number of lines passed through this one? Then EA cos theta. Okay, total number of the lines is nothing but flux. So here flux is equal to, what is the formula? Phi is equal to EA cos theta. Now come to the Gauss law. So now I take a surface area enclosed this charge. Now this area is enclosed charge. Suppose ఇప్పుడు మనము క్లాస్ రూమ్లో ఉన్నాం కదా. సపోజ్ క్లాస్ రూమ్లో ఉన్నప్పుడు యు ఆర్ ఇన్ ద క్లాస్ రూమ్. ఓకే, సో నౌ యు ఆర్ బౌండెడ్ ఇన్ ఏ క్లాస్ రూమ్ like this one. Suppose you are the charge, you are the charge. Now room is, now I take the irregular shape. Okay na? Okay, irregular shape assumption చేసుకుందాం. irregular shape లో ఉన్న రూమ్లో నువ్వు ఉన్నావు. you are in sitting the irregular shape of the room. Suppose you are the charge, so charge is bounded in a closed surface. So this is closed surface. So now charge is enclosed. Okay, so from the charge we know that number of field lines are coming from this charge. Yes or no? Three dimensionally. So through this surface area some field lines are crossed. Okay, so it is better thing in two dimensional. Okay, now this is the charge. Okay, so here charge is there. From the charge electric field lines are coming out. Okay, so these lines are passed through this irregular shape. Now I take the regular shape. Suppose this is the regular shape. Okay, look here, this is the circle. Actually two dimensionally we get the circle, but this imagination is applicable to three dimensional. Then circle become sphere. Okay na? So what is the concept here? So this is irregular surface, a regular shape, and this is the shape, regular shape. Okay, what is the regular shape here? That is the sphere. Okay, so ikkada number of lines passed through irregular shape is equivalent to the number of the lines passed through the regular shape. Yes or no? ఇక్కడ irregular షేప్లో ఎన్ని లైన్స్ పాస్ అవుతున్నాయో రెగ్యులర్ షేప్లో కూడా అన్ని ఫీల్డ్ లైన్స్ అనేది పాస్ అవుతున్నాయి. రైట్? So number of lines are passed through irregular shape is equivalent to number of lines are passed through sphere. Okay, so same flux, number of lines is nothing but flux. So flux through any irregular shape is equivalent to the flux through the sphere. So what is the surface area of sphere? That is formula is 4 pi r square. Okay, surface area of the sphere formula is 4 pi r square. So what is the pi formula? Pi is equal to E into A. So charge is here. Okay, suppose this is the field line vector. This field line is vector is perpendicular to this point. Okay, you know this is the normal line for the circle. So any normal line is perpendicular to at this the point. Okay, so for perpendicular, so use this formula pi is equal to EA. Okay, so next pi is equal to, what is the E formula? We know that 1 by 4 pi epsilon naught q by r square. What is the area here? that is 4 pi r square, area of the sphere. So r square cancel, 4 pi cancel, then we get cancel, and r square cancel. See here we get q by epsilon naught. Okay, 1 into q is 1. So finally we get q by epsilon naught. So flux is equal to q by epsilon naught. This is Gauss law. So what is the statement here? So we know the formula we get pi is equal to q by epsilon naught. So statement here, so flux, pi mean flux through any closed surface. So this is important, closed surface is equivalent to 1 by epsilon naught. Okay, q by epsilon naught is nothing but 1 by epsilon naught into q. Okay, into mean times, so 1 by epsilon naught times of net charge. Q mean net charge enclosed in that surface area. So this is Gauss law statement. Okay, మనకు 4 మార్క్స్ ఇచ్చినప్పుడు ఇక్కడ నుంచి స్టార్ట్ చేయాలి. ఫస్ట్ రైట్ ద స్టేట్మెంట్. వాట్ ఈస్ ద స్టేట్మెంట్? ఫ్లక్స్ త్రూ ఎనీ క్లోజ్డ్ సర్ఫేస్ ఈజ్ ఈక్వలెంట్ టు ది 1 by epsilon naught times of net charge enclosed in that surface area. So what is the Gauss formula? Pi is equal to q by epsilon naught. First point, Gauss law is applied for only closed surface and closed charge. Okay, now we take here charge is enclosed in the space. Okay, but charge is not a open. Okay, so this is the first point. Next, second point, Gauss law gives a relation between electric field intensity and charge. You know what is the Gauss formula? Pi is equal to q by epsilon naught. So what is the pi? That is Ea cos theta. Okay, so for regular electric field lines we take this the formula, that is Ea cos theta mean E dot A. Suppose we take the vectors E and A, then E dot A. E dot mean Ea cos theta. Okay, dot E dot A mean Ea cos theta. Okay, suppose field lines are irregular, then you use the mathematical concept, that is calculus subject. So here total meaning, that is we get the integration total. Okay, integration is nothing but total. For what? Electric field lines through area, that is E dot ds. Integral E dot ds mean total number of electric field lines. So what is the here? Pi is equal to integration E dot ds is equal to q by epsilon naught. So here E and Q there. So this is a relation between electric field intensity and charge. Gauss law is valid only if Coulomb's law is valid. So it is based on Coulomb's law. Okay, so in the formula derivation, so we use E is equal to 1 by 4 pi epsilon naught q by r square. Okay, so this is formula coming from Coulomb's law. Coulomb's law is valid, then only Gauss law is valid. So there are some other forces like as a gravitation force, nuclear force. Okay, in such a case Gauss law is not applicable there. Next, Gauss law is valid for only stationary charges. Okay, charges are in rest position. We know that when the charge is rest position, it creates electric field lines. Suppose charge is moving, it creates electric field and also magnetic field lines. Electric field lines and magnetic field lines are created. So it is not discussed about magnetic field lines. Charges should be in rest position. Rest position is nothing but stationary. Okay, so Gauss law is valid for only stationary charges. Okay, these 4 points are important in Gauss law. సో ఈ గాస్ లాకి 4 మార్క్స్ అడిగినప్పుడు స్టేట్మెంట్, ఈ స్టేట్మెంట్తో పాటు ఈ 4 పాయింట్స్ రాస్తే మనకి 4 మార్క్స్ వస్తాయి. ఓకేనా?